Hi, grade 12. Welcome to grade 12 Financial Mathematics. And this is our first session. It is session 1. And I just want us today to just start with revision. And we'll just be revising grade 11 and 10 finance. And in this session, we'll focus on growth, decay, and interest. Okay, let's quickly look at the lesson outline. So in this session, we'll focus on three things, right? Number one, we'll focus on what? We'll focus on problems related to growth, right? And we'll be using simple interest and compound interest formulas. And we'll also secondly focus on problems related to decay. And here we'll be using simple or straight line method or compound or what is known as reducing balance method, and it's also a revision. And lastly, we'll focus on the nominal and effective interest rates, and this is basically also a revision. Okay, so I want you to kindly note that most examples that are used in these sessions are exam kind of examples, so they're extracted from Department of Basic Education past exam papers. So don't, maybe you might start to say, no, I know simple interest, I know compound interest, I know simple decay, I know what, and you might start to undermine. Don't do that, right? So I just want you to focus because there's much to learn in this lesson. Okay, let's start. Okay, we're gonna start with simple interest and compound interest, and this is a recap, right? So simple interest and compound interest formulas, they are used to calculate the growth of an investment, right? So the growth of an investment. So an investment can either be growing by using simple interest rates, or it can either be growing by using what? By using compound interest rates, that is being compounded. And you know that for simple interest rate, the formula is A is equals to P into 1 plus IN. So that's the formula. Okay, so for compound interest rate, the formula is A is equals to P into 1 plus I to the exponent N. Can you see? So we know that where A, it's the accumulated what? The accumulated amount, that is the value of the investment, that is it has grown to, right? For example, if I invest 50 rands today and maybe after 1 year I'll get it as 70 rands, so my A there will be what? Will be 70 rands, because it's the accumulated amount or the growth value of an investment, the grown value of the investment, right? So P is your original amount, right? The initial invested amount, or the one you deposit, or sometimes it can call the deposited amount, right? So it's your P, the one that you deposit when you want to invest, and something like that. And I is the interest rate, right? Is the interest rate. Don't forget our I. We'll just write it in what? In decimals, right? So if I'm given 15% as the interest rate, so my interest rate, there is I, I'm gonna put 0.15 because we just put it in decimal. But sometimes you can just leave it as percentage, there's no problem, but just know we just need it in decimal like that. Okay, N is the period for investment, and this is mostly in years, unless otherwise it's compounded like that. We'll explain. So if I invest for 1 year, my N will be 1 because it's the period of that investment. Okay, so let's also talk where you also use your compound interest formula. Okay, so your compound interest formula can also be used to calculate population growth. It's not only about investments only, but you can use it to calculate what? The population growth. For example, they can give you maybe a population of people growing like that, and they say determine what after 10 years, how many, what will be the number for the population, or how will the population grow. So we use the compound interest formula to calculate that, right? Also for inflation, for example, you know that prices are always increasing every year, right? They're inflating like that every year. You'll find that if you go and you ask 3 years back how much you bought a pen. Maybe you bought it by 3 rands, but if you go today, you'll find maybe they're costing 5 rands because of inflation. So if things are inflating, they inflate in an exponential way. So hence we have to use what? We have to use the compound interest formula to calculate that growth like that. Okay, so now with compound interest, you must know that it can be compounded. That is, the interest can be received at certain time intervals. And this is different as compared to simple interest, because simple interest is always given per annum, right, per year. So there's no worry there. But with things that are being compounded, you can compound them annually, yearly, that is per year once, right? Or they can be compounded semi-annually, that is half yearly, and that is 2, right? 2 times per year. And they can be compounded quarterly, right? Quarterly, we have how many quarters? We have 4 quarters, right? So it's 4 times per year. And it can be compounded monthly. How many months do we have in a year? 12 months, or daily, right? Sometimes they can even say weekly, and for weekly it will be 52 per year. So what do you do if you find that your interests are being compounded like this? So what you do on your interest, if it's compounded semi-annually, it means, because semi-annually is 2 per year, so on your interest you're gonna divide it by what? By 2. Then on your number of years, let me just write it, number of years, you multiply it by what? By 2, because they must be converted to that compounding period, so that we cannot make mistake. For example, if you are getting interest semi-annually, it means your interest also must be semi-annually. How do you do that? You divide the interest by 2 as you lend in grade 11, and you also multiply your number of years by 2, so that everything may be converted to semi-annual. So if it was quarterly, I was going to divide my interest by what? By 4. Then on my number of years, I multiply with what? With 4, like that, so that I can convert all my things to quarterly like that. Okay, so let's quickly just go and look at an example for this. Okay, this is our first example, interesting one, simple interest and compound interest example. So this is problem solving. So they're saying KWV invested 5,000 at 15% simple interest per annum for 5 years, right? Okay, we can see this was simple interest, and we can see per annum for 5 years. Then BMW invested 5,000 at 12% compound interest per annum for 5 years. Which person gained more interest on their investment? Substantiate your answer, and this is by showing all your calculations. Okay, so we're gonna calculate the accumulated amount by KWV, right? And we're also gonna calculate the accumulated amount by what? By BMW. Okay, so KWV invested 5,000. It means that the invested amount, the initial amount is 5,000, which is our P. And here we really need the accumulated amount. What is the interest? The interest is 15% simple interest. This is the same as 0.15, right? So it's basically 15 divided by 100. So you'll see it's 0.15. And this is done for 5 years. So the number of years is going to be 5 years. Then we can go and use the formula. So we are guided here. They are saying simple interest. So the formula must be for simple interest equals to P into 1 plus IN. So my P is 5,000 into 1 plus my interest is 0.15 multiplied by what? Multiplied by 5. Okay, so I can get the answer for that. When I punch the calculator, the answer is 8,750. Okay, so it means that this person is going to get 8,750. Let's go to BMW. For BMW, invested 5,000 also, so his P is 5,000, and we need to know his accumulated amount, right? So his interest here, it's 0.12, or I can just write it as 12%, which is 12 over 100, which is 0.12 compound interest. So this is compound interest, right? So it's compound interest, don't forget, for 5 years. So the number of years is 5. So per annum, we divide the interest by 1 and we multiply n by 1, so it won't change. So A is equals to P into 1 plus I. The formula will be different because this is compound interest. So our P is 5,000, oh sorry about this, 5,000 into 1 plus our interest is 0.12, and our number of years is 5. Okay, so just punch a calculator and get the answer. Okay, so the answer will be 8,811.71. Okay, so 0.71. So you can see that the person who gained more, it's BMW. So you conclude that BMW is the one who gained what? Who gained more. And you can see he gained more because he got 8,811.71, and this one got 8,750. So if you'd want to invest, definitely you'd go for what? For compounding interest, right? Because it seems as if it's the one that gives more. So obviously this is applicable in real life. If you want to invest, you can just, if the bank asks you, do you want to invest in simple interest or compound interest, definitely go for compound interest. Okay, we are still on simple and compound interest, and I just want us to focus on this different interesting example. Okay, so they're saying, how long will it take for a motor car to double in value if the annual inflation rate is 8.5%? Okay, so they're saying, how long will it take for this motor car to double in value if the annual inflation rate is 8.5%? So we are given the rate there, it's 8.5%, right? So the word inflation rate, when they use inflation, we know that the formula that we're going to use is for compound interest, right? So it's for compound interest because it's used also for calculating inflation. Okay, so now they didn't give you much of the information, I mean in values, but they just give you a simple instruction. They say, how long will it take? So they want what? They want n, can you see, for a motor car to double in its value. So our A is the accumulated value, right? So but they didn't give us that value. They just say for a motor car to double in its value. So I can let the initial amount to be what? To be x. Can you see? The initial amount to be x. Then my accumulated amount, I'm told that to double in its value. Then it will be what? To be 2x, because the initial amount is x. So this one will be what? Will be 2x. Or sometimes if this thing for x can confuse you, you can just, okay, the initial amount is p. I don't know it, but I just want to know how long will it take when it's doubling in its value. So our A will be what? Will be 2p, right? Because we are doubling the initial amount. So like that. So we can go and substitute where there is A. I'm going to put what? I'm going to put 2p because they say to double in its value. So where there is p, it will remain p. 1 plus the interest is 8.5. So 8.5 divided by 100 is what? Is 0.085 exponent n. Now we have to solve for n, right? What can we do? We can divide both sides by p. So we can divide both sides by p, then p will cancel p there, then we'll be left with 2 is equals to what? 1 plus 0.085 exponent n. Okay, now to solve n, because it's on the exponent, you can use logarithm, right? you can use logarithms. Sorry about that. Logarithm. So there's a log rule that says if I have maybe something like 2 is equals to 3 exponent x. So in order to solve for x, my x will just be basically be log of base 3 into 2. So that's actually how you can solve for that x if maybe the base are not the same and you cannot raise it to the same base. So you can simply say x is equals to log of base 3 to the exponent to what of 2. So even in this case, what I can do, my n will be equals to what? Log of base this one, which is 1 plus 0, 0.085 into what? Into 2 there. And you can just use your calculator because your calculator has a log of base and something there. So you punch your calculator and you get the answer. Okay, when we punch a calculator, we are getting n is equals to 8.5. Okay, so our n will be equals to 8.5. So if I can just convert 5 into months, so you can see it's 8 years and what, and 5 months. So I can just basically convert that to say it will be basically 9 years. Okay, so how long will it take for the car to double its value? It will take what? 9 years. Because if I say 8.5, okay, you can just write 8.5 years, but just to be more precise, we can just convert that to be what? To be 9 years. So this is quite a bit challenging question because you are not given the value of A and P, but they just give you an information that you can use in order to solve this. They just told you for a motor car to double, so it means the accumulated value must be 2 times the initial value, which is our P. You go and substitute. Also, you had to know the log rule in order to solve your n there on the exponent. Okay, let's now look at a different example. They're saying Peter invests 12,500 for K years, right? So at a compound interest rate of 9% per annum compounded quarterly. Is it? They're saying at the end of the K years, his investment is worth 30,440. Then they want you to calculate the value of K, right? So you can see this is compound interest, so we know we have to use compound interest formula, and we must know the value of A, that is the accumulated amount. It is 30,440. P, the initial amount that was invested, it's 12,500. Okay, 12,500. The interest is 9% per annum compounded quarterly, right? So if the interest is compounded quarterly, we know we have to go and divide it by 4 to just convert it into quarterly interest. Number of years is K because they say K years, so we're just gonna substitute there and get the answer. So it will be 30,440 is equals to 12,500 into 1 plus the interest is 9%, which is 0.09. Because it's compounded quarterly, we have to divide it by what? By 4, and just to convert it into quarterly interest. Our number of years is K, so we know also on number of years, because this compounded quarterly, to be K times what? K times 4. Okay, so now we can now go and solve for K. I think to do this, we're gonna just divide both sides by 12,500 first. So divide both sides by 12,500. This one cancel out this one. So we'll be left with 1 plus 0.09 divided by 4 into 4K, right? Is equals to 30,440 divided by 12,500 on your calculator. It will give you 2.4352. Then to solve for k, we can see our k is on the exponent. We have to use log rules, right? Don't forget, I just show you if you have 2 is equals to 3 exponent x, because the base are not the same and you cannot change 2 to the same base as 3. So you can use log rule to say x is equals to what? Log, our base will be this one 3 and this one will be here 2. Log of base 3 2. So that will be your x there if you had something like that. So going back here to solve for my k, it's now 4k there. So just basically say 4k is equals to what? The log of base what? 1 plus 0.09 over 4, and you just put it in brackets there, into 2,4352. So you have log on your calculator. You can just press this on your calculator to get the answer. Okay. Okay, let's move to our second part. We just want to focus also on decay or depreciation. Decay or depreciation. So with decay or depreciation, you find that something is losing its value. For example, the phone that you bought 1 year ago, if you want to sell it this year, you'll definitely not sell it with the same amount that you bought with, because over time items may depreciate. Although there are some items that appreciate instead of depreciating, such as a house. We know that a house, if you buy a house, maybe if you bought a house 10 years ago, if you want to sell it maybe in the next coming 2 years or so, you'll definitely sell it with a higher price because it appreciates over time. But most of the items, they depreciate, that is, they lose their value, right, over time. For example, such as a phone that you bought 10 years ago, if you want to sell it today, just imagine you'll sell it at a very low price, because over time it has loosened its value by being used and all that. So losing its quality, also losing its value. So now that value of an equipment at a given time after depreciation has taken place, we call it what? The book value. For example, I'll just use a phone to say I bought a phone 3 years ago and I want to sell it now. Maybe I bought it by 500 then, but now because it has depreciated and all that, when we go and calculate, we find that you can sell it by 200 instead of 500 or more. You can go and sell it by 200. So that 200 will be called what? The book value. So it's the value of that equipment at a given time after depreciation has taken place. Okay. So now we also have the scrap value. So don't confuse the book value with the scrap value. Although the scrap value, it's also the book value, but it's a book value that is different, right? So we said the book value is the value of an item or the equipment after depreciation has taken place. So this one is when an item is still functioning, right? It's still functioning. But what if maybe I just bought a phone 3 years ago and the phone is no more working and I want to sell that phone? Definitely it has depreciated because my phone is no longer working. It's no more a useful item. It's just a scrap. So the money that I will sell my phone with, it's called what? The scrap value. So it's actually the book value of the equipment at the end of its useful time. So that is when that item is no more functioning. Okay, so there are two ways in which items can depreciate. They can either depreciate on a straight line, and this we call using simple interest. So here it depreciates based on the straight line method. So also number two, it can depreciate on compound interest, that it depreciates on the reducing balance basis, right? So there are two different formulas that you can use. It depends on what the question is telling you. So if they tell you that depreciation is on a straight line method, you use the formula for simple interest. But be careful, because this is depreciation. You cannot put plus there because it's losing its value. It must be what? Minus. Don't forget to do that. Okay, so depreciation using reducing balance or compound method. So it's of a compound interest, but the sign is minus because it's actually losing its value. Okay, let's just quickly go and look at an example to help you understand this. Okay, here's an example. They say calculate the original price of a laptop if its depreciated value after 5 years is 800 and the rate of depreciation was 12% annum, calculated using a straight line method and also a reducing balance method. So for A, the formula that we use on a straight line method is P into A equals to P into 1 minus IN, right? So you have to know what is A. So our A here stands for the book value, right? Or you can say the scrap value sometimes, scrap value, right? So our P is the original amount of the item. So this is the original amount of an item. So our I is what? Is the rate of depreciation, and our N definitely is the number of years or the period of depreciation, or the number of years. Okay, so you can see that your A is your book value. That is the value that you'll get after depreciation has taken place, right? So that is your A. But our P here is not standing for like the invested amount. No, we are talking about depreciation. Our P is the original amount of the item. To say if I bought a car by 200,000 and I want to sell my car in the next 5 years, how much can I sell it with? So my original amount of the car was what? Was 200,000. So on our P, we're just gonna put that. Okay, let's just go and answer this question. Okay, from the question they want what? The original price. In other words, they want P, right? So you are given that the laptop depreciated value after 5 years is 800. It means the laptop has reduced to 800. So your A is your book value. That is the amount after depreciation has taken place, and we can see it's 800 there. Then we want our original amount. We want P. 1 minus, what is our I? Is 12%, which is 0.12. After how many years? 5 years. We put 5 there. Then we can solve for P by dividing both sides by 1 minus 0.12 times 5. Divide both sides by 1 minus 0.12 times 5. Okay, so this one will cancel out this one. Then we'll be left with P being equal to 2,000. Okay, so our P is 2,000 rands. So you can see that on a straight line method, so the original price of the laptop was initially what? Was 2,000 rands, was 2,000 rands. Okay, let's go and do it on a reducing balance method, B. Okay, so on a reducing balance method, we know that this is using compound formula. So, but because it's depreciation, the formula will say 1 minus I exponent N. So we want to calculate the original price. We want P. Our book value is given as 800 equals to P into 1 minus our interest is 0.12. Our number of years is 5. Can you see? So to solve for P, I'm just going to divide with 1 minus 0.12 exponent 5 divided by 1 minus 0.12 exponent 5. So this one will cancel out this one. Then I will solve my P and the answer will be 1,515.92. So that was the original price on reducing using reducing balance method. So that will be the original price of the laptop. Okay, let's focus on a different problem. They're saying a car cost X rand, right? The value of the car decreased by R% annually on reducing balance method. Okay, so this is a key statement. After 42 months, the book value of the car is half of what it was worth when it was bought. So the question says calculate R. So they want the depreciation rate, right? The rate for depreciation. So they used, they told you the method, it's using reducing balance method. So the formula we know, it's A into P into 1 minus I exponent N, right? So what's the key statement here? The key statement is that the book value of the car, that is our A, right? We know that A stands for book value. That is the value of the car after depreciation. Is now half of what it was worth when it was bought, right? So we can say our A now is now half the original price. And we know that the original price is what? Is B, is P, sorry, is P. So our A will be equals to 1 over 2P. Can you see? Because they are saying the book value now is now half of what it was worth when it was bought. So our P is the original amount of the car, the money that the car was initially bought with, right? So now our A, which is our book value, it's now half of what it was worth when it's bought. So you just say A is equals to 1 over 2P. So when there is A, I'm just gonna put 1 over 2 what? P is equals to P is the original amount of which the car was bought. We don't know it. We'll just leave it as P, right? 1 minus, what is the interest? We want to calculate the interest. It's R%, right? So exponent N, you know that N must be in years. And now they give you your N as in months to say it's 42 months. So to convert months to years, we divide by what? We divide by 12. So our N will be 42 divided by 12, which is 3.5 years. 3.5 years. Can you see? So when there is N, I'm just going to put what? 3.5. Then I can go and solve for my R. Can you see? So it was a little bit tricky like that. Okay, so to solve for my R, I can first start by dividing both sides by P. So this P will cancel this P will cancel this P. Then I'll be left with 1 over 2 is equals to 1 minus R% to the exponent of 3.5. Okay, now to solve for my R, I can apply the root of, I mean, it's not the root. What can I call it? Because it's not even the third root, the 3.5 root of that thing, both sides. So in order to cancel out that 3.5 there, so I can apply the 3.5 root of 1 over 2 both sides. 3.5 root, here we have 1 minus R% exponent 3.5. Just to, we know that we want to cancel that 3.5 on exponent, so we just apply the 3.5 root of that. Okay, so when we do it this side, I'm just gonna use my calculator. So it's the 3.5 root of 1 over 2, and it's giving me 0.82. I'm just gonna copy everything. 0.820335356 is equals to, here when we apply the 3.5 root of this one will cancel out that one, and we'll be left with 1 minus what? Minus R%. Or let me just leave it like that. Let me not put it in bracket. So to solve for R, I'm gonna take 1 to this side, right? 1 is positive. So the mistake that most students do, they just assume 1 is negative, but 1 is positive. What is negative is your R. It's minus R%. So 1 is positive. Be careful there. So when you take a 1 which is positive, that side is gonna be what? Negative. They're gonna be 0.820335356 minus 1 is equals to negative R%, right? So let's go and use a calculator to solve that. Okay, so when I subtract 1, I'm getting negative 0.179664644 is equals to minus r%. To solve for r, I'm gonna divide by negative 1. Can you see? Let me just put it somewhere here because of space. Okay, let me just write like this. So my r% when I divide by negative 1 is gonna be 0.1796644. Is it 646? Okay, 6. So this is 664644. Then I can convert it into percentage by multiplying by 100, right? So r% when I multiply by 100, it's gonna be 17.97%. 17.97% as the what? As the rate of depreciation there. So we can now conclude that indeed the value of the car decreased by 17.97% on reducing balance method. So that's basically how we do it, and it's quite a tricky question like that. Okay, let's now focus on the nominal and effective interest rate as part of our recap. So effective interest rate and nominal interest rate, you must know what they mean. So the effective interest rate is the rate where the stated period and the compounding interest are the same, right? For example, it's where you find maybe they are telling you the interest is maybe 5% per annum compounded yearly. So you can see that the period is per annum and the compounding period is yearly, and annum and yearly, they're the same thing. So we call that interest rate an effective interest rate. Can you see? So and this is most of the times in order to understand it, you must just know effective interest rate. It's mostly always compounded annually, right? Compounded annually or yearly, something like that. But really, this is just where the period, the stated period and the compounding period are the same. Now with the nominal interest rate, it's a rate where the stated period and the compounding interest are not the same. They are different. For example, they can give you 5% per annum compounded quarterly. So you can see that the stated period per annum and the compounding period are not the same. This is compounded quarterly, but the money is given per annum. I mean, the percentage is being paid per annum like that. Okay. So, oh, sorry about the background noise. This side. Let me just sort it out. Okay, it's fine now. Okay, so that will be nominal. So mostly the nominal you'll find is those interest where they're saying compounded monthly, compounded quarterly, compounded what, whereas they're being given per annum, but they're being compounded differently like that. It's where the stated period and the compounding interest are not the same. Is the nominal interest. Okay, so how can we convert? You must know, and this is very important to learn in grade 11. So how can you convert between effective and nominal interest rate? How can you convert between the two? Maybe you want to convert. You might be given an effective interest rate and the question says get the nominal interest. You must know how to convert in simple, very simple. This is the formula that you use in order to convert. It's saying 1 plus IF. IF is the effective interest rate. As you can see, they've indicated for you it's effective interest rate, and it's mostly annual, right? It's mostly annual. It's this one that is just like annual. It's compounded per annum, and it's like compounded yearly like that. It's annual like that, right? It's always mostly annual. Okay. So the nominal interest rate is the one that will be compounded differently, like the compounded monthly, compounded quarterly is the nominal interest rate. So the formula says 1 plus IF is equals to 1 plus I nominal, or I nominal divided by M to the exponent of M. So M is the number of compounding periods, right? So the number of compounding periods. For example, if they are compounding monthly, if they're compounding monthly where there is M, I'll put what? I'll divide by 12. and also where there is m there, I'll put 12. So because it's monthly, so it's the number of compounding periods. If semi-annually, I'll divide by 2 my nominal, and also put 2 there at the exponent. Okay, notice, very, very important also, note when you convert a nominal interest rate from another regularity of a compounding to its equivalent value in a different regularity of compounding. That is, if you want to convert between nominal interest rate and another nominal interest rate, there's a formula, right? For example, you can be given 5% per annum compounded monthly, and you want to convert it into a different interest that is compounded differently, maybe compounded semi-annually. You want to convert the rate compounded monthly, we know that is nominal, in another rate that is compounded maybe differently, that is semi-annually. We also know that is nominal. So how do you convert now between nominal interest rate and nominal interest rate? You just use the formula for nominal interest rate, you equate it with the other one. So because here we used m, here we'll just use n to show that these are different compounding periods. So if it was monthly this side, I'm gonna put 12 there. If it was semi-annually, I'm gonna put 2, so that I may get one of the interest that is needed there. So this is how you definitely convert between nominal and nominal. And you must also know, very, very important, because they can give you a question and they can tell you that the money is being paid per month, right? But maybe the interest is given per annum, per annum, per annum. It means that before calculating, you must first make sure that also the interest is the same as the way in which the money is being given, because it does not make sense if you are getting interest per year and you are paying every month, right? You must get interest also per month. So that's where you need to convert that interest that is per year, and you convert it into what? Into the interest that is per month. And this is the formula that we definitely use to do that. Okay, let's just quickly go and look at an example. Okay, here is it, very quick and short. So they are saying convert a nominal interest rate of 18% per annum compounded monthly to an annual effective rate. We're just going to use the formula 1 plus IF is equals to what? Is equals to 1 plus I nominal divided by M, all to the exponent of M. So we want to solve for what? For the effective interest rate. So it will be 1 plus IF is equals to 1 plus, what is your nominal interest? Is 18%, which I'm just going to write it as decimal to say 0.18. So it's compounded monthly. I'm just going to divide by what? The compounding period is 12. Also put 12 there. So I want to solve my effective interest rate. I'll take 1 to that side. So it will be 1 plus 0.18 over 12 exponent 12 minus 1, right? Just going to use a calculator to get the answer for that. Okay, when I punch a calculator, it's giving me 0.195618, something like that. Going forth, I can convert this into percentage by multiplying by what? By 100. So let's just quickly multiply by 100. When multiply by 100, it's going to be 19.56%. So this will be our effective rate, which is mostly like annual, like that. Okay, great stuff. This marks the end of our session, and we were really doing this revision on financial mathematics for your previous grades, right? So our next session will be session 2, where we'll be focusing on the new added knowledge on finance, that is the financial mathematics for grade 12, and that's our session 2 that is coming next. Otherwise, thank you very much for watching. If you're new to this channel, just make sure you've subscribed, like our video, and also just drop your comments so that we can hear your views on these sessions. Okay, otherwise, that's all for me, and goodbye.